In this video, we're going to talk about thermostats, and we're specifically going to talk about thermostats with regard to their use in air conditioning. Okay, thermostats are used in refrigeration, in heating, in electric heat, gas, oil, and all sorts of different places, but I want to specifically focus on our conversation regarding air conditioning. The basic function of the AC thermostat is to turn the system on and off. And it does it automatically, and it adjusts it to room temperature. A basic thermostat does not sense humidity. It only senses sensible temperature. Now let's go back and remember, sensible temperature is temperature I can measure. Latent temperature, or which is basically part of humidity, is temperature I can't measure, but is heat or lack of heat, heat addition and heat removal, having to do with the change of state, like from water to humidity. Thermostats must be located on an internal wall, and closer to the return vent is best, and this is due to air mixture. Okay, if I pull the room air across it, I'm going to get a mix of the heated air and the cooled air or unheated air. Most thermostats with air conditioning are 24 volts, and this is for safety. We don't want to have 120 or 240 volts where people can get to it, especially kids. So basic digital thermostat is shown in this picture here, but they all have the same makeup. Okay, a thermostat has a sub-base, and the thermostat mounts to the sub-base. The sub-base must match the thermostat. It has all the wire terminal connections, and it's a location for any switches. And you want to have these things level. It isn't as critical anymore as with mercury thermostats, but your customer is going to be very appreciative of a thermostat being level. So this is just an example of a sub-base. This is a great example, a little bit older of a thermostat, but it shows where you have all the wiring connections are up here. You have mounting holes where you can actually adjust if this is level or not. You can actually throw a short little level across the top of this to make sure it is level. And then you have some sort of electrical contacts that actually connects to the thermostat cover. Most often on the older thermostats, your heat, auto, and cool switches were right on the sub-base, as well as your fan on and auto. And that becomes important from a troubleshooting standpoint. Another example of a sub-base actually has a thermostat this is where the thermostat mounts on the sub-base. Okay, you'll notice here you really don't have any wiring connections you can access directly from the top, which is where the thermostat's mounting. All of your wiring connections are underneath. Another example of a sub-base, this is for the old round thermostats, the Honeywell T80s that you've seen forever. Okay, again, we have all our wiring connections down here. They're labeled. We'll go into the purpose of all these later, but we have our system switch here. We have our fan on, and on all of these, there was a little pin where you could sit a level across them because leveling these was extremely important. And this is just a thermostat top. Now, again, you don't see these that often in the field anymore, but this little pointer down here, the little copper pointer, this was your heat anticipator setting, which was normally set to the amperage of your gas valve or the amperage of the relay that it controlled on the low voltage side. Okay, most of these thermostats do not have an adjustable cooling anticipator. They are set for a constant. But the heating anticipator could be adjusted. So the thermostat itself, not the sub-base, is where the temperature is sent. The action will close a switch and turn the AC system on. The indoor blower coil is energized in air conditioning mode. So once the cooling turned on, in other words, the R to Y terminals closed, energize the compressor and the outdoor fan, the indoor fan motor comes on at the same time. So we have four types of thermostats. We have a mercury bulb, which you don't, that's almost gone. You don't see them that often, but they're still out there and you have to know what to do with them. The biggest and most important thing on mercury bulb thermostats is A, they have to be level, and B, you cannot just toss them out in the dumpster. Mercury is a hazardous waste. The second one is the bimetal or snap action. The third one is the Helix coil. And the fourth and final one is the solid state. More and more thermostats are either going to be the snap action or the solid state. When we start looking at the thermostat terminals and the functions of each terminal, every single wiring terminal on the thermostat has a specific function. Try to use the correct color wire, or if it's unavailable, make sure you use the same color on each side. Okay, make sure if for example, if you have to use a blue on the thermostat on the Y terminal instead of a yellow wire, use the blue on the air handler or where it connects to. Stay consistent with your wiring. Thermostats are connected with a rated T-stat wire, normally 18 gauge, and it could be 18/4, 18/6. Just tells you it's 18 gauge and how many conductors are inside. Make sure you try to have a thermostat wire with at least one additional conductor that you're not using in case something goes bad someplace along the way. Do not strip and expose too much copper. Keep the areas that you strip down as short as humanly possible and make a good connection. So the thermostat terminals, and every thermostat will have one or more of these. Okay, RC, it's the 24 volts from the air conditioning transformer, which is normally in the air handler. Y is the cooling contactor coil. Standard is yellow, but it could have another color on it. Make sure you look at the terminals. Y2 is second stage cooling, could be blue. G is the fan relay coil, should be green, or again, just have the same color on the thermostat side as you do on the air handler side. O only is applied if you're using a heat pump. That's a reversing valve, and normally that's orange. RH could be 24 volts from a heating transformer if it's a separate transformer. W would be the heat relay. Most often a white wire is used. W2 is a second stage heat relay. Can use any other color wire. Just again, get the same color on both sides of the system. C stands for common, and that's normally black. Now, just to point out, RC and RH sometimes are jumped together, okay, with a single wire feeding both. That's perfectly normal and okay. It just, again, depends on the system setup. So make sure if you're changing a thermostat, you know how the one you're wired was there first was wired, so you can get the wires back in the right space. Make very sure that RC, RH, and C wires never touch together if the system is energized. So the best idea is to wire thermostats with the system disconnected. In other words, the breaker turned off. So this is just a couple different thermostat diagrams. Okay, this is a basic cooling thermostat here. Just has R, Y, and G. Okay? Basic cooling thermostat. That's your minimum required wires for a cooling system. Then we can jump over to our next one, adds a heating mode, R, W, Y, and G. Then we can go to, we have two separate systems. Here we have an RH and an RC. RH is the heating transformer, goes to W. RC is the cooling, it's probably in the air handler. Then we can come down here, we start getting more and more complicated. Okay, this is a heat pump. We have a B terminal. Now, what's the B terminal? I thought I mentioned the O terminal. It's the exact opposite. In this case, the B is energized when we're in heating mode. Okay, in this case, the O is energized in cooling mode. So it's the exact opposite. And here we have a multi-stage system. Two-stage heat, W1, W2. Two-stage cooling, Y1, Y2. Don't worry about the heat pumps for right now. We're going to get into that much deeper when we get into heat pumps. So let's talk a little bit about digital thermostats. They work the same as non-programmable, but they're more sensitive, and most of the time they're more accurate. They have a time delay built right into them, which delays the compressor from starting if pressures are not balanced. And it sometimes prevents the compressor from tripping on an overload situation. The digital thermostats have battery backups to store temperature settings so you don't lose everything if power goes out. This is an example of a newer Honeywell digital thermostat. A lot of these will also do outside temperatures, outside humidity. They're programmable. They'll do indoor humidity, and there's a lot of functionality with all of these. Okay, this is just the thermistor temperature sensing element that you find in most digital thermostats. There's the thermistor is a part that inside there, the resistance of it will go up as the temperature increases. Programmable thermostats makes the system completely automatic. The manufacturers do say they save money, but you do have to be careful with how wide of a temperature swing you give. Each thermostat is different, and most have the information right on the inside of the cover on how to program them. Okay, operation of the thermostats has several basic settings. 4 functions. You might have wake, leave, return, and sleep. Wake is for the first thing in the morning. Leave is what the temperature people set it to when they go to work. Return is when they come home. And sleep is the overnight. So again, we might be doing a temperature swing. Overnight, we have 60 degrees. Wake up, bring it to 70. Leave for work and school. Evening, sleep. Okay. Now, this could also be set the same way over a 7-day period. Now, 10 degrees is an awful large swing for a programmable thermostat. Probably not recommended anymore because every time you do a large temperature swing like that, you have to deal with humidity and the load of the house. Okay, can't forget that there's a lot of mass in the house that has to be heated and cooled. Programming the thermostat, all are basically the same. 5-day, 2-day, 7-day, 7-day, with each one being different. When switched over to manual or override, the override usually lasts 2 to 3 hours or until the next scheduled program. 5 to 8 minute time delay for air conditioning. Most will have no time delay for AC if the cooling has been dormant, in other words, not running for 1 hour. Always look at the inside of the cover because most of the time there's a quick reference there. This is just a picture of a snap action. Okay, you'll see in here that there's some contacts. The linkage snaps back and forth depending on what the temperature is. Another picture of a snap action, okay, has a little magnet on it. And when this gets close enough, it's going to snap in. So this doesn't bounce back and forth, creating electrical issues. Another picture of a thermostat with a mercury bulb. You'll notice the wire connections coming off here. Okay, we have down here, we have one wire. We have a common in the center. We have the blue up top. And we have a brown on the bottom. Okay, so if the thing goes this way, okay, if the mercury bulb tilts this way, it gives a connection from blue to brown. That's going to be our heating side. If this would tilt up in the other direction, the mercury would come back to the left-hand side of this bulb, and it would complete a circuit between the blue and the yellow. Okay, that would be our cooling. There's very thin wires in there that it connects to, but it has a big glob of mercury. Mercury is a hazardous material. Okay, this is an example of a heat anticipator with a Helix coil. Okay, that little resistor is actually a cooling anticipator. It provides a little bit of heat when the system is not operational, so that the thermostat will come on slightly before the set point is reached, and it makes it just keep a more accurate inside temperatures. And just a couple diagrams of how we deal with anticipators, okay? So up top here, these are 2 cooling circuits, okay? You have your thermostat here, closes on temperature rise, and if you look close, there's a resistor right in parallel with that thermostat. So when the thermostat is open, okay, this cooling anticipator is powered and provides some heat that will eventually help close that cooling thermostat. Over here, the cooling anticipator is, or the cooling thermostat is closed, while current takes the path of least resistance. There's less resistance through the anticipator or through the thermostat than there is through the anticipator. So the anticipator gets no power. Okay, contacts that close on a temperature rise is what a cooling thermostat is. And if you look at a package unit, you'll find a lot of times that the thermostat is actually put in front of the air in, uses what's called a remote bulb. So again, thermostat is your central point of control in all systems. It's critical that you know how they're wired. It's critical that you follow wiring diagrams and know how things are wired if you replace a thermostat. Safety step, make sure you turn the power off before you disconnect and rewire a thermostat.